Okay, so yeah, you're not on camera. I'm not trying to put anybody's face on or anything. It just starts recording. Here's what I say. Actually, that transcript is available, so I don't know if I have people that have maybe English is not their native language. You will get the spelling of everything I say and what the word is over there as you hear it on the recording. You can go look at the transcript. I do have to. Oh man, I forgot. No, I think it still worked. I forgot to share my screen in the other recording, but I think it still worked. So all it records is whatever is up there. That's all it's recording. And my voice, obviously. It hears me, but can't see anything I do out here, so you wouldn't see that, obviously. I'm not using the camera on the computer, is what I'm saying. All right. So what is the answer to an equation? Who had the good answer? Did I say yours was really good, Nadia? Were you one of them? All right, so what did you say again? Variable, and then what did you say, Griffin? Was it you? Oh, who said me? I told somebody that their answer was pretty good for number one.
Oh, you can double check your answer.
Oh, yes, check. You said you can double check your answer. What did you have, Kira? Oh, no water in here. So here's what the answer represents. So we have an equation. I think I already wrote it, but I'll write it again. We have that equation. Is that an equation right there? I'll kind of cover the other. What makes an equation versus an expression? Equal sign. Only one or two people had that. A lot of you put one's got variables or one's got multiplication, addition, subtraction. No, they both have variables. They both have numbers. They both have addition, subtraction, division, any math operation. What makes them different, that's an expression. There's no equal sign. There's no other side. Oh, somebody did say there's only one side. There's not a left and a right side. That's a good answer also. An expression doesn't have this equals that. It's just got some numbers and variables and math and that kind of stuff. You can't solve that. We don't know, okay, what do I do with that x plus 3? As soon as I do this, and I make a second side, a right side, I can say, okay, well, if I know this side, this left side, sides are determined by where the equal sign is. If I know the left side has to equal the right side, because an equation is a what? The two-word thing. Equation is a four-letter word. Starts with R. Rule. An equation is a rule. That's the other part of the definition for an equation. This side has got to equal that side. That's the rule. We cannot break that rule. Well, the only way to not break that rule and to fill in a number for x is to make x 4. That's the only number that will not break that rule. So x would have to equal 4 because that's the only way we can keep the left side equal to the right side. So the answer to number 1, what does an answer to an equation represent? I'm about to give you the definition. So write this down. I see everybody writing.
Is that number 1?
Yep. But I'm waiting for some heads to pop up. Well, one end. Everybody should be writing what I'm about to say. There he is. He's up. All right. Need to see you writing this. This is an answer for a quiz. Answer for a quiz. Come on, man. Let's go. Vámonos. I'm about to tell you. I'm waiting for you to get to a page. Make sure it's dated. Today is the 19th. So this bell work should be dated the 19th. It should be labeled. It should be labeled as bell work. So that way you can find it. Because I might tell you, yeah, we did it for bell work that day. Oh, it's not one of my students. Leaving at 9:45. Probably. Oh, not yet. Oh wait. Oh yeah. Alex, did you know you're leaving? You didn't know you're leaving? Oh, okay. So you got 10 minutes. So we'll get through this and then leaving at 9:45. That. I'll talk about that in a second. Yes, ma'am. Oh, really? Must be somebody sitting right where you are. I haven't. Oh, I forgot. I keep forgetting to even announce the birthday.
Haven't given us an answer yet.
Willow, happy birthday, Willow. Does anybody want to sing happy birthday? I can't sing, but I will.
John does.
Hey, John, you want to sing with me?
Yeah, sorry.
I'm not singing all by myself. If anybody else will sing, I'll sing.
I can say it.
You need me, Brooklyn?
Yeah.
We're gonna sound so
Yeah.
good.
No.
Ready?
No,
Chicken. Chicken.
I'll do it.
We'll do it fast. Let's do it fast. We're gonna sing it really fast. You gotta keep up with me. I don't even know if I know the whole happy birthday.
Alright, you ready?
Hold on, I gotta think about the song. No, we're singing it fast. We're doing it fast. We gotta get through it. And plus, that's easier to do. It takes the pressure off. Yeah, that's only 4. All right, ready? I'll lead. You just kind of catch up. All right. Happy birthday to you. Not that fast. Ready, here. Happy birthday to you. Happy birthday to you. Happy birthday, dear Willow. Happy birthday to you. We could do you know the other birthday song? What is it? By 50 Cent? They're short each birthday? It's your birthday. It's your birthday. It's your birthday. I used to play that all the time. Every once in a while I'll play music in here. I'll play some of my favorite songs and you'll be like, but then by the end of it I'll have somebody that's getting into it every time. I'm not going to tell you what that song is. I used to play the song from Frozen, Let It Go. I love that song. Love that song. That's the favorite song. All right, so here's the definition you write down. So you should have written that, or you could write the answer to an equation. The answer to an equation. I'm giving you the answer to number 1. The answer to an equation. I'm trying to say it the same way I said it in the other class. But I don't know that. Is the number. And I'm going to use a word that actually 2 words I'm going to spell out for you in a second. So the answer to an equation is the number that we substitute. That's a math, well, it's actually, it's an English word, but it's got a math definition. So I'm going to write it up here. So if you don't know how to spell it, substitute. The definition in math is really the same as it is in anything like sports. I always use a sports reference because it's literally the same thing. If you substitute into a game for somebody, they come out, you go in. None of the other players do anything different. They're still in. You're just taking one player out, you're going in. That's all substituting is in math. We're going to take the x out and substitute a number in for x. So it's the number that you substitute for the variable. Variable's already up here if you don't know how to spell variable. So it's the number you substitute for the variable. I'll let you get caught up with that. You know all that already? Man, oh man. I will say 100 times. I could literally say it 100 times. Write this down. Write this down. Write this down. I've said it just keep saying it. And then when I actually give the definition, somebody will not be writing it down. It's like just zone out. It's funny. So the answer to an equation is the number that we substitute for the variable that makes the left side of the equation equal the right side of the equation. So I'll say all that again because I know I said a lot of things.
That's for number 2.
No, she'll give me the answer for number 1. We've already done number 2, but since you were absent, I'll go back over those 2. I mean, a different day, not today. Yep, I'm gonna say the whole thing over again. But I'm just giving some people are writing what I just said, so I'll give them a chance to finish that part. And if you didn't get it all, I'm about to say it again. Whole thing again. I'm gonna put a timer on so we can stay on track. So we need 30 minutes to do the final lesson, and then the exit ticket. We get out at 10:49. So we need to start at 10:19, which is 30.
Did the white copy on her. Let's go.
Almost.
I'm blind, you know that.
All right, there we go. Oh, remember, we don't say stuff like that. I know you guys know each other, but that may make other people uncomfortable when we say negative things like that. So keep it positive. You can. I don't even love the laughing, but people won't realize what you're laughing about. They think that you guys have an inside joke or something going on. But don't say stupid anything about people's answers or anything about the math part. I don't care how well you know each other. We are positive, positive, positive when it comes to the math part of this class. Now, if you want to make fun of him about his hair, that's another nonsense. Don't make fun of my hair. I did used to, I didn't show you my picture. I actually used to have hair. I have a picture of it. I showed
Can you
one.
show?
I have a little thing that I used to do every year at the beginning where I go through like about me, but I didn't do it this year, but I will do it at some point.
I'm sorry.
You guys need to bring it down. You're at about a 9. You need to be at about a 5. You don't understand what that means? That means bring it down. All right. So last time, the answer to an equation is the number that we substitute right there for the variable. Should have already had that. That makes the left side of the equation equal the right side of the equation. Remember, this is recorded. If you didn't get all of that, either get it from somebody or go back, watch the video real quick. All right, and you'll know where to go to the video because you'll see this still up on the board. So, now we got to move on though. So, what is an equation? Oh, make sure you're dated because I guarantee you that will be on a quiz at some point as well. Because if you understand that, that makes equations much more simple. You still have to know how to do some math, but that's a huge, huge important concept for equations. What is an equation and how is it different from expression? I kind of went over some of this. An equation is just a rule. The rule is really the same all the time. It's that the left side has to equal the right side. That's the rule. Now, in this case, the specific rule is x plus 3 has to equal 7. But the real general rule is just the left side has to equal the right side. That's why we put an equal sign there, because this has to equal that. So that's what an equation is. It is different from an expression. One person, maybe a couple had this. How's it different from an expression? I just told you a second ago too. What is it?
It doesn't have any signs.
It doesn't have an equal sign. It'll have addition, subtraction, multiplication, all those possibly. It doesn't have an equal sign. So technically, every equation is 2 expressions. One on the left, one on the right. 7 is technically an expression. X plus 3 is technically an expression. It's not a very big expression, but it is. And that side by itself, there's no equal sign just over here. That side, there's no equal sign. Put them together, though, and put an equal sign in between them, now it's an equation. So an equation is made up of 2 expressions, and you just set them equal to each other. You don't have to know all that last part. Just know that an expression doesn't have an equal sign. An equation does. So therefore, if we have an equal sign, we can solve for the variable. If we don't, we can't solve for the variable. All we can do is simplify it, which we did last class. All right. Now, I don't know how this is going to record because I'm not doing anything up on the smart board. I'm just doing it in front of you guys. So it'll hear everything, but I don't know how well that's going to work out with people that listen later. We're going to do a little visual demonstration, I guess we do that. Not really activity. Demonstration. But I need a volunteer. Who wants to volunteer? Bricklin! Come on up. You really actually don't do a whole lot, but
What do I do?
almost nothing now. I mean, the last person that volunteered last class didn't really do a whole lot, but I still want you to come up. Come on up.
It's a choice now.
You're primarily answering questions, but everybody primarily answers them. No, you are for this. Come on up. It's too late. You already volunteered. Come on. Too late. Let's go. Come on. Come on. You raise your hand. You volunteer. Let's go. Now you're cutting into my time. Let's go. Come on. Exactly. It'll be difficult.
Do you have the Alice in here?
Oh yeah, I'm sorry, Alex. It's your time to go. Actually, you still got a minute or two, but you stand right there for now. I'm going to start asking you some questions. So, I got a bag right here. Where he's just going to the front office?
Yeah, you're my way
What's that?
from me.
Okay, he'll be on his way. Thank you. Yeah, we talked about it and I totally forgot to keep track of the time. All right. This is easy. I have a bag right here, Alex. Alex. You said Alex's name. Bricklin, I have a bag right here.
What?
So everybody, I'm really talking to all of you. I mean, I'm going to look at Bricklin. I have a bag right here. Inside this bag are Tootsie Rolls.
Yes.
How many Tootsie Rolls are in here?
4.
Would you bet your life on that?
Hell
Why not?
no.
How many Tootsie Rolls are in here?
4.
I'm
0.
10?
0.
Would you bet your life on that? Why not?
Yeah.
Why wouldn't you bet your life on that?
But you can't
Cut
see
it.
what's in it.
So
There's
what-
none in there.
What is
There's
this
none.
then?
Jesse.
Say it again. Jasmine's all over it. Did you hear that? What do you remember?
A variable. Yeah.
This is all a variable is. It is an unknown number. There's a number of Tootsie Rolls in here. You don't know what they are. You don't know what that number is. I've told you it's Tootsie Rolls. You don't know how many though. So I'm trying to give you a visual demonstration of what a variable is. So hopefully it sticks with you because we're going to get into more complex stuff. So the more you understand, the better off. So this is a variable.
I'm a.
Because you volunteered.
I don't know.
Why'd you volunteer?
I didn't want. I thought it was.
Oh, you were volunteering to just kind of answer something.
Yeah.
That's fine. All right, I have right here. What's that? Tootsie Rolls. I have a Tootsie Roll. Can you tell me how many Tootsie Rolls I have here?
1.
You see it, right? That's a 1. That is 1 Tootsie Roll. I can write an expression now. What would I write if I want to know how many total Tootsie Rolls?
0 plus 1.
Is it 0? Do I have 0 here?
Yeah. Maybe.
Maybe, but do we know that? Oh, by the way, why is this a variable, we said? Because it's an unknown number. That's all it is. Unknown number. We do know what it is. We know it's Tootsie Rolls, but it's an unknown number of Tootsie Rolls. So here's your expression. When you get an equation, it's all an equation, all expression is. Think of the variable as a bag of some type of candy. In this case, I used it.
I don't know.
Guess what else I have over here?
Shut up.
All right, not gentlemen.
Each other alone.
Gentlemen, I said you were at a 9 a little while ago. You're still at the 9. I need you down around a 5. Because otherwise, you're right. You won't be up here doing a demonstration anymore. You can be somewhere else. It's not what we want to do. Guess what I have here?
Another bag.
Bag of Tootsie Rolls. Guess what? Same number of Tootsie Rolls in here as in here.
What? Wait, that sounded like it had nothing in it.
It didn't. You're right. It didn't sound like a lot. Well, maybe there's not a lot in there. So, same number of Tootsie Rolls. What do I need to add to that expression?
Plus.
It's an X. It's the same number. We don't know what that is. Every variable, though, has the same number behind it or in it, if you want to think of the bags. Let's add another X. That's what I have over here.
Oh my God.
Another bag.
Tootsie Rolls. They actually have X. Same number of Tootsie Rolls are in this bag. What do I need to add to that?
Another X.
Go sit down. Biggest whiny little complaining little volunteer I've ever had. Man. Not yet. Even though this is a simple, goofy thing, I think it does help explain a couple of things. The next thing. So that's my expression. I don't know what's in any of these, but I do know they're always the same number. And always the same type of candy, we'll say, or item. What can I do with that right now? I wanted to solve, well, if you solve it, we're going to talk about solving it in a minute. What can I do with that expression? Here, Jasmine's on top of it. What do you mean 3x? What are you talking about? Jasmine just said that. Why is she saying that?
Because there's 3 X's.
We just added 3 x's together. It's just 3x. Technically, though, what's that math? 3x. Well, what's the math going on? What is 3x? What's the math going on with 3 and x? That's what I wanted to say. Remember, 3x is this. Gotta understand that. Like, again, that's one of the most basic things you need to take out of Algebra 1. The number next to a variable means 3 times that variable. Because think about it. If I were to ask you, I'll give somebody this in a second. I'm going to ask, actually here, I'm going to give it to you. I want, who am I going to call on? Izzy, since your head's in. Izzy's tired. I'm still going to call him. Izzy. Izzy, wake up. I got a math question for you. Math problem, really. I want you to add, yeah, you do. You're a smart kid. I want you to add the number 2, like 2, over and over and over again. I want you to add the number of 2 11 times. What do you get?
2, 4, 6, 8, 10.
Anybody know it yet?
26.
Wait, who said it? Nadia?
Yeah.
Did you say it? How'd you get that so fast? How'd you add it way faster than he had
That's
it?
11.
Isn't that like 222?
Are you?
Close. Not 3 2s.
Three
Remember, you
twos.
can have double of it.
You can double it, but what did you do?
I know my
Say it again. If you're adding the same number over and over and over again, 2, for example, which is an easy one to add. 2 plus 2 is 4, plus 2 is say blah, blah, blah. All you're doing is you're just doing a shortcut of 11 2's times the number 2 is 22. Adding the same number over and over and over again, we can just use a shortcut of multiplication point. So if I'm adding this, because remember, we know this is the same number. We don't know what that number is yet, but that's fine. Whatever that number is, I'm just going to multiply it by 3. That is a shortcut to addition. That's why we can say this is 3x. Because I'm just saying, okay, I'm just going to multiply 3 times whatever number of Tootsie Rolls I have in. That's all 3x is. So think of x as an unknown number of Tootsie Rolls. So a bag of Tootsie Rolls, and we don't know how many are in there. And then when we do 3x, all we're doing is we're just saying, okay, well, if I have 3 bags of Tootsie Rolls, I need to multiply that times 3. 1 bag times 3. So and then we'd still have the plus 1, because we still know we have that 1 Tootsie Roll. That's fine. Last thing, just again, a little bit of a visual. What do you think I have here?
4.
Well, we don't know. Again, we just have a bag. Right? We got another bag. These are lifesavers.
Why?
Not Tootsie Rolls. We don't know how many lifesavers. Did you say it? Actually, you said it too, but I don't think you meant it the same way. What did you say?
Why would be a different year?
Damn, read mine. Look, Gregory can read mine.
What? I'm so wrong.
You actually just said Y, but you were actually saying WHY. This is a different candy. I can't say this is an X because it's not Tootsie Roll. This is Y. This might be a different number than what's behind this. No, it could be the same. It's possible that they're the same. But if you see 2 variables, the reason why you have 2 different variables, think of it, 1 is a bag of Tootsie Rolls, 1 is a bag of Lifesavers. And we don't know how many is in any of the bags. But whatever is in that bag of Tootsie Rolls is in the same number of Tootsie Rolls in each bag. So what would I need to do to my expression? If I want to add, like I want to know total pieces of candy, not total Tootsie Rolls, what would I need to do with this? Just plus Y. I just say, okay, well, if I have this many Tootsie Rolls and I want to know total pieces of candy, I need to add in the pieces of Lifesavers, number of Lifesavers. What if I have 1 more bag of Lifesavers? What do I do? Again, same number of Lifesavers. So I could say plus Y again, because that's going to be the same number of Lifesavers, same number of Lifesavers. And then if I shortened it, I would just say that could be 2Y So 3x plus 1 plus 2y. So you're going to get into some stuff. We won't get into a whole bunch of stuff with two variables in here. Mostly it'll be about one variable. And if we do have two variables, we won't normally have a coefficient to the second variable. Next year, though, you're going to get into this a lot. That's why I'm trying to prepare you more for the tests and for your EOC next year than just doing some math in here. Variables are just a bag of candy, and we don't know how many pieces are in there. If it's a different variable, it's a different candy. But the key is every bag of candy, so every bag of Tootsie Rolls has the same number of Tootsie Rolls. Every bag of Lifesavers has the same number of Lifesavers. If we had another variable, think of it as Jolly Ranchers. I don't know, come up with your own candy. Every bag of that had, like, let's say it was plus 4Z. Well, that just means we got 4 bags of Jolly Ranchers, and every bag has the same number of Jolly Ranchers in it. So I'm trying to take a little bit of the mystery out of variables for you there. And then as far as combining them, 3 times X just means we had 3 bags of them. 2 times Y means we had 2 bags of Lifesavers. 4 times Z means we had 4 bags of Jolly Ranchers. All right, hopefully that helps a little bit. If not, doesn't hurt. If you didn't already know, then it didn't hurt your understanding of it. I hope. I don't know how it would have. Oh boy, oh boy. I won't be able to deal with that all year, gentlemen. Probably not next week. I don't know what's so funny, but you guys sitting across from the room, that's disruption. Oh, that's mine now. I'm glad I saw that. I'm glad I saw that.
Oh, now you want to wake up.
Now, I can put up with a lot. I'll tell you right now, you'd be written up in most classes.
Oh, sorry.
So just remember that. Mr. Gill has a breaking point, too. Other teachers would have already had you written up. Because I guarantee you, right now, I get rid of one of you, solves everything. Guarantee you. Because the first person that gets written up and out, I don't have any problems after that. So if I feel like you're jeopardizing the learning of my classroom for other students, you'll be out. So just watch it, because you're already pushing it. Already pushing it. Any questions on that? Again, I'll give you information that's sometimes what's called conceptual. It's understanding. I think Gregory said it earlier. You don't really have to take a lot of notes during that. I'm just trying to give you kind of a mental image to clarify stuff that may have never been explained to you. Now, when we do process stuff, that's when you have to take notes, or when I give you definitions and that kind of stuff. Here's what I need you to do now. Everybody come up. I'm going to move some of them to the other side of the room so that you don't all have to come to one spot. I don't believe I had actually passed these out last class. I didn't remember that. Come up and grab one, or does anybody like passing stuff out? All right, come up and grab one of those, not these. I get rid of these. Come up and grab one of those. If you're on this side, you can go there. If you're on this side, you can come over here. I'll just put them on my desk. So just grab one of those. We're about to do 2-step equations. And this is what your quiz is on. There are 2-step equations on today's quiz, as well as some definitions that hopefully you just have in your notes. Good time, yep. You want to run real quick? You do need to put your phone in there, though. Here's my thing on sleeping. If you sleep, I'll wake you up off and on. I get some nights you had a rough night or whatever. I'm recording the classes. If for some reason you had a really rough night and you have to do it, I've woken Izzy up a couple of times. He's still putting his head down. I'm done. It's on him now. No, he's still taking the quiz. So he's going to take the quiz. He's probably going to fail it. So it's going to be an easy quiz. So instead of getting 100, he'll start with a 0 or whatever he gets. I mean, he should still have some notes from other days. I'm not your babysitter. I'm not here to babysit you and hold your hand. It's not middle school anymore. You need to become accountable for your grades. Leo, are you up? Leo. So Leo's back up again. I'm not going to keep doing that. He falls asleep quite a bit, so I've done this. If he doesn't pay attention right now, if he winds up failing the quiz that we have on this stuff later, he's got to start being accountable for it. There's also a manual pencil sharpener back there. It didn't work great last year. I don't know if they replaced it or not. All right, so I'm going to give you, these are, so you need to label what we're about to do, two-step equations. It says it right on your paper, so it's not hard to spell it, but you need to put that in your notes. Two-step equations. We will, 40% of your EOC next year, your algebra end of course exam, your FSA, 40% is on solving equations. So that's a lot. Not quite half the test, but almost half the test that you have to pass to graduate is on solving equations. So if you get really, the good news is if you get really good at solving equations, probably going to be in pretty good shape for that end of course exam. Now, some of the questions aren't just here's an equation, solve it. They are going to kind of ask you questions about equations, and you have to have some understanding. But remember, oh wait, that's the wrong one. Remember when I did the magic trick? I did the magic trick about guessing numbers in here, right?
No.
Well, you probably weren't here. I did it last class, so you weren't here. You've actually missed 2 classes. I don't know why my computer doesn't do that right, but here we go. So in that magic trick, well, I guess I called it a magic trick later. Maybe I didn't call it a magic trick. Remember, I guessed a number. I started telling people I could read minds later. I wasn't allowed to in here, but I probably didn't do it like that the first day. The second day I didn't. So I started telling people I could read my. Oh, that's not. Huh. I'm going to go backwards a little bit. So I said, start with a number, multiply it by 3, subtract 2, and then you get an end number. So that x is a number, like it's a variable, but it's an unknown number. Then you'll have an ending number. Well, we said all I did was I built an equation, and then I solved it to figure out what your starting number was. So the equation that I built was just your unknown number. So I started and I said, okay, I don't know their number. And then I need to multiply that number times 3. Then from that, I need to subtract 2. And then I asked you what your ending number was. That's what allowed me to, because right now all I have is an expression, right? I don't have another side. I don't have an equal sign. So I had to come up with the equals some number part. And you guys maybe told me, oh, my starting number is 10. That's what I filled in that allowed me to now solve, to create an equation and solve it. So how did I solve it? What's the first thing I had to do? Well, the first, that's what solving it means we're trying to find x, but what was the first thing I did to start solving the process? What was the process? Well, I went backwards. I started with the last thing that you did, and I did the opposite. So that's one of the keys. If you don't remember anything from today, when you're solving an equation, a two-step equation, it's all about doing the opposite math from what's already in the equation. So in the equation, I'm subtracting 2. What's the opposite of subtracting 2? Add 2. So I do the opposite. But what's Mr. Gill's #1 rule of solving an equation? You need to write this down if you weren't here 2 days ago. Mr. Gill's #1 rule of solving an equation. Yes, sir. Bam! Nailed it. If I do, I'm going to say it for you. If I do something on one side, so this is the correct first step, I add 2. But if I do something on one side of the equation, it doesn't matter which side I had to start on, in this case it's the left side, but if I do it on one side of the equation, I have got to do it to the other side. Otherwise, if you'll remember the scale thing, it's like putting something on one side of the scale and not putting anything on the other side. So the scale is going to be out of bounds. I have got to keep this equation in bounds, which means the only way to do that is if I add 2 here, I add 2 over there. And it doesn't matter what the math is. If I subtract something on one side, I can subtract it on the other side. If I divide on one side, I can divide on the other side. If I multiply on one side, I got to multiply on the other side. So, next step. I do the math. The 2's go away now, because I undid the 2 to get rid of it. I did the opposite math to get rid of it, because I want to get x all by itself. I don't want the 2 anymore. I don't want the 3. So I got to get rid of the 2 and the 3. So then I had 3x equaled now 12, because if I added the 2 over here, I get 12. So what's my next step? Last step. Next step and last step. What do I do now? Yeah, I got to divide. Because remember, the original thing I had you guys do when I guessed the number, you multiplied by 3, so I had to undo that to figure out what your original number was. I had to do the opposite. Well, if you'll notice down here, we have multiplication going on. 3, that is 3 times x. It's not, this x does not represent multiplication. It's a variable. When I say 3 times x, if there's no math being shown, then that means multiplication. So that's 3 times x. I need to do the opposite math, which is division. And if I divide by 3 on that side, I divide by 3 on that side, x equals 4. And going back to our bell work, if x is the correct answer, because I remember the question was, what does an answer represent in an equation? That's the number that better make the left side equal the right side. So if I plug this or substitute this back in, 4 times 3 is 12. 12 subtract 2 is 10. Well, yes, 10 equals 10, so it works. That's how I know it's the right answer. So when I plug it back in, it works. Yeah, you're gonna have to get caught up because you're gonna have a, well, you just picked up the worksheet, but I just went over one example, so you should have that example written down. I would say put your phone in there, but we know where it is. All right. So if you want to get started, like if you like this is boring me to death. Now some of the equations on there are harder than this. You'll see there's fractions involved. But if you think you can figure it out, it's really just still involved. Oh, let me give you this one piece real quick. Well, I'm trying to see. I already did these notes somewhere. I'm trying to see if I have them or not. Looks like I don't. Oh, that's same. See, that's the same equation. I just did. I picked a different ending number. All right. I'll just. I have them here. Oh, we already did that example. So money. I guess I'll just do them on this screen. That's fine, because I'm going to erase it anyway. So here are your steps to solving a 2-step equation. So you may want to write that somewhere and make sure you can find it later, because like I said, 2-step equations are going to be a big part of your grade for this quarter. This whole quarter will come probably every test or quiz you have will have at least one 2-step equation on it. Some of them will have harder equations, but they'll definitely have a 2-step equation. So in solving 2-step equations, or when solving, or you could write the steps to solving, whatever works better for you. Step 1, you start with the constant. I didn't write this up in the last class. I should have, I guess. I just told him, listen. Actually, I may save this. All right, so I'll read it out loud in a second, but if you can read that, fine, from wherever you're at, you can just copy it. So the first step So solving a two-step equation, you start with a constant that is on the same side as the variable. And I'm going to leave that up there, but I'll go back. Well, actually, I'll rewrite it real quick. So I just had 3x subtract 2 equals 10. I added the 2 first. That was my first step. The reason it was my first step is because I had to go in reverse order, but again, just following the steps rules here. That is, 10 is also a constant, right? 10 is a constant, but it's not on the same side as where the variable is. The 2 is on the same, or technically negative 2, is on the same side as where the variable is. So that's what we have to start with. That's the first step. I'm going to have to get rid of that equation probably. Maybe not. No, I can write below it. That's fine. Yeah, I'll just write in a different color so it stands out. So step 2. And there's only 2 steps because it's a 2-step equation. There are some, I guess I should say this, there are some 2-step equations that don't follow these 2 steps exactly. I don't typically use those, but just so you know, and I've said this before, I think, in this class, I hope I have, if not, I'm saying it now. I'm doing stuff for this class. When you go to the full algebra class next year and you have a different teacher as well, there could be exceptions to this. I'm talking about for this class. Anything you see on a quiz from me will follow these steps. All right, so the last step now, again, I need to do the opposite math. And you're actually doing the opposite math here also. So start with that and do the opposite math. Actually, I'm going to tell you what, I'm going to make that its own separate thing because that's pretty important. And then last step is typically division. Almost always really division. Well, boy, now that I say that, you're actually, nah, I'm not, I'm going to take that away.
Step 4.
I'm taking step 3 away because a bunch of the problems on the worksheet we're going to do today, the last step isn't division.
You want us to erase that?
Yeah, scratch through that. Most of the time, we'll just leave it there for today. We'll add more to it as we start doing longer equations. Most of the time it will be division. Today just happens to be one of the exception days because, again, I didn't create that worksheet. So it's a little different than what I would have given you, but it's still good practice. So now I'm going to do a couple of examples for you, and then you'll have the exit ticket. Oh, crap. Oh, no. That was just to start the lessons. We're actually ahead of time. So look at your worksheet that I just gave you. I'm going to do, I'll do number either 1 or 2. Do you have a preference? Somebody say 1 or 2. 2. All right, so I'm doing number 2. So number 2 is a little different than what we just saw in the other one that was 3x subtract 2 equals 7 or 10 or whatever number you want to use. It's got a fraction to start. Which again, you guys freak out when you see variables, which is why I do that whole thing to try to take the mystery out of variables. Then you freak out when you see fractions. Should be number 2, I think. Is that how? I'm not done writing it. Yeah, but is that the way it starts? I have 2 different sheets of this. One time I grabbed the wrong sheet. So this is the 2-step equation. It is only 2 steps, even though it looks significantly different than the other one. Even though this looks harder, it's not. You just got to think about it a little bit more because it's not as common as some of the other 2-step equations that you've probably seen. And you did do 2-step equations already last year, maybe even in 7th grade. What's the first step? What did I say the first step? Should have just written it down. Well, again, it's not always the same math. So you got to look at your steps. Is it Aiden? Aiden. Aiden, right? Just write it down. What's the first step? But you got a quiz in 15 minutes. Leo, you got a quiz in 15 minutes. I'm going over what you need to know right now.
Is this our quiz?
This is what your quiz will be like. I'm going to do another easier one in a second. This is actually the hardest one that's on there. So don't freak out too much if you can't do this one. What's the first one? First rule say?
Start with the constant.
I need to start, but what's the rest of that? Start with the constant what? Because there's two constants, right? What are my constants in this? Yeah, I got two constants. The constants are the ones that are just numbers, not with variables. This number is with a variable. It may be division, but it's with that variable. So that's not a constant. These are constants. That is a constant, and that is a constant. I got to start with one of those. So I start with which one? Same side as the variable. So I start with that one. So that's how you determine where you start in a two-step equation. Find the one that's the constant, which means there's no variable with it. And it is on the same side as the variable. It's just not like right with the variable, like the 2 is with the variable. So I need to then, the only other step you have to think about is the opposite math. What's the opposite of adding 5? Subtract 5. So I subtract 5. So even though there's fractions involved, it's still the same step that it would have been if this was not, if this would have just been 2 times in, I would have still done the same step. Now, what's the most important rule, though? Mr. Gill's most important rule. I'm gonna let somebody else know. What is it? Yeah, if I subtract 5 here, that equation is no longer in balance if I only do it on one side. I've got to get it back into balance. So I need to subtract 5 over here. Again, if you want to get started on that sheet, if I'm boring you, you can go. Just start working on it. Did somebody not get it? Oh yeah, because you're nappy now. Did you have it, Leo? All right, then come up and grab one too. So now I have 1/2 of the problem done. If I do, well, I gotta still do the math. So that goes away, which is the whole reason I just subtracted 5. I'm trying to get rid of the numbers. That goes away. N divided by 2 there equals, I'm not going to go over why it's the case, but 3 subtract 5 or 3 plus -5, it's the same thing. That equals -2. So now this is what I have. I did the first step. For the second step, I just kind of stay with that last step. I do the opposite math again. What's the math going on? What is this n over 2 thing? What's that math going on? Division. That line means divide. If you don't understand that, or if you didn't remember that, you need to write it down again. That's what that line means. Anytime you see variables, numbers, whatever, over more variables and numbers, the line means divide. N divided by 2. Well, if division is the math going on, what's the opposite of division? Multiplication. So I need to multiply, and you always multiply by whatever the number is on the bottom. On that side, you kind of have to make it a fraction. On this side, you don't. You just say times 2. Because we don't have a fraction on the right, so we don't need to make it a fraction. So here's what happens. Again, I'm not going to go into a long explanation about the math part. The 2's cancel out over here. It basically becomes 2 divided by 2. So 2 divided by 2 is just 1. But we still have the n. This didn't go away, and we don't want it to. We want to keep the variable because that's what we're solving for. So we still have the variable n over there. And then we just say, okay, what's -2 times 2? Negative 2 times 2. What's the number part? You should know the number part. No, times. It's negative 4. Good. So let me go over the rules very briefly. I'm not worried about your math. You could make a bunch of math mistakes on this quiz and still get an A. I'm not super concerned about the math. I just want to know that you're following the steps. A negative, this is for multiplication and division. If you have a negative and a positive, or a positive and a negative, same thing. If you multiply or divide, negative and positive, that is always a negative. If you have a negative and a negative, again, multiplying and dividing, it is a positive. It's different for addition and subtraction. It depends on addition and subtraction. You could sometimes get a positive, you could sometimes get a negative. I can't give you a specific rule for that. If you really want to learn it, though, I have a video on adding positive and negative integers. It's on the YouTube. It's like probably 4 minutes long. Maybe it's not super long. So that's an example of a more difficult one. I have an example already of the easier one. So I'm going to put that up. How do I do? Oh, there we go. That right there. How do I scroll? Oh, there we go. So you have up on the screen an example of a more simple two-step equation where there's no fractions, basically. You also have, oh man. Oh, wait. There, I'll give you those two examples, because now you have an example of each. There, so here's an example of a simple one. It was 3x subtract 2 equals 10. Well, I started with the number that's the constant, but on the same side as a variable. I did the opposite. So I'll write in, oh, I gotta do this. So this was plus 2. In case you can't see that, I'll write it in red. So if I did plus 2 there, I had to do plus 2 there. Then my last step in that was this was multiplication. So my last step was I had to do division. Over here, it was a little different. Over here, I still start with the constant that's on the same side as a variable. I did the opposite math, so that was plus 5, so that's subtract 5. If I do that, I got to do that. My math in the equation, though, right there, that's division. So I need to do multiplication, the opposite. So start working on that worksheet. We're going to take the quiz at, I'm going to give you 15 minutes, even though it doesn't take 15 minutes. So 35, we'll say. So you've got about